Caitlin Orr, and I'm going to be doing my presentation on the startle response and habituation of the blue mussel to continuous shipping noise playbacks. So around the world, the oceans are getting louder with low frequency noise coming from shipping, and we just want to understand how that affects key reef building species. So the present study, conducted at Edinburgh Napier University within the Aquatic Noise Research Group, looks at the effects of continuous shipping noise exposure on blue mussels over a period of 5 hours. So if you want to find out more about the study and about results, then please do come along to our presentation.
Hi, I'm Susan Fitzer, a Research Fellow at the Institute of Aquaculture. Ocean acidification and global warming present future challenges for mussels. These valuable aquaculture species control their shell growth through biomineralization. But under ocean acidification, shell growth is limited due to reductions in carbonate. It is unclear how this carbon is taken into the shell from environment versus food resource. Shell growth is energetically costly to mussels, and enhanced food supply could alleviate any negative impacts on growth. We assess this under experimental ocean acidification using carbon isotopes to assess biomineralization pathways. Mussel metabolic carbon uptake into the shell increased under ocean acidification, and additional food resources increased further to compensate. Algae responds differently to ocean acidification, and changing resources could maintain metabolic uptake for mussel growth.
Terrestrial studies can, for example, use satellite imagery to map biomass, but unfortunately this approach is not applicable to deep-sea habitats. As a consequence, no biomass maps are available for cohort reefs to date. Since biomass is useful to calculate carbon turnover, carbon stock, and to quantify the importance of the different supply mechanisms of organic matter to the reef, we developed a novel approach to map cold-water coral reef biomass. To learn about our methodology, watch my presentation during the Tuesday morning session.
The restoration of native oyster reefs in the northeast Atlantic is now widespread. However, the biodiversity outcomes of restoration programs are poorly understood. In this study, we used scientific divers to take videos and photos of the oyster bed in Loch Ryan, one of the last remaining natural oyster fisheries in Scotland. The fishery operates a 6-year rotational harvest system, and we surveyed plots which had been harvested 1, 2 and 6 years previously. We found that megafaunal biodiversity increased the longer the plot had been left undisturbed, and a link between oyster shell density and biodiversity. These results are discussed in context of the Dynamic Environmental Enhancement Project and restoration initiatives.
Restoration of biogenic reefs such as those formed by coral and oysters have been developed over time and have reported on successes and failures. This has provided a great opportunity to learn from previous projects for future oyster restoration in the EU. In this study, active coral and non-European oyster restoration projects were reviewed and analysed to determine progress in terms of survival and if key components of project design, such as spatial scale and length of monitoring, affected survival of restored reefs. After analysis, these design components showed no effect on survival, but oyster reef survival tended to be lower than that of coral and decreased over time. This study also highlighted other issues in restoration, such as a lack of transparency, consistency in monitoring, and as well as a lack of long-term monitoring. So it will be important to address these issues as we move forward with oyster restoration in the EU.
The waters of the northeast Atlantic are notoriously busy, but oyster restoration is gaining momentum and becoming increasingly popular. In the Dornoch Environmental Enhancement Project, we aim to restore 4 million oysters. But where do we put them?
In the DEEP project, we processed all the available information to minimise conflicts between nature conservation interests and stakeholder interests. We processed data collected using several different techniques. By a process of elimination, we arrived at the most suitable areas for oyster restoration. In so doing, we have minimised conflicts between the nature conservation interests and stakeholder interests.
To avoid disturbance, seasonality of restoration activity also needed to be considered, and mitigation measures put in place. This is the first high-resolution analysis of oyster restoration potential in a marine protected area.